So today is Wednesday, January the 25th, okay? So we want to kind of talk about the lab, the results. Hopefully you've been working on them and getting all of the calculations done, but I kind of want to go over now to make sure that you know exactly what you're doing and how to do it. So the first thing that we needed to do was get your concentration. So I went up here, and so everybody's concentrations, really those calculations should all be the same. Okay? So everybody's going to get 0.08, 0.08, pardon me, 0.064, 0.048, 0.032. So we can kind of see the 5 and 7 is a double. Then we do the exact same thing for D. And you end up getting the exact same concentrations for D. So when you're filling in your chart, when you're filling in the chart, you want to just be filling in those concentrations or where they're going to go. But you need to show your work for each one. But again, you don't have to show when it's all exactly the same. Now, if you did that, you'll live. It's not that big of a deal. Okay? So now we have our concentration. So then we had to calculate the rate. So again, remember, when we're doing this, the rate is the rate of disappearance of the S208 divided by time. So we had to calculate the concentration. How much did the S208, how much of it actually reacts? Well, that's where the S203 comes in. Because we put the S203 in, that was our limiting reactant. So when it got used up, that's when we knew then that's how much iodine. We're using that. So we went through the 5 milliliters, which is 0.005 liters, times the concentration, and it was a 1 to 2 ratio. So we know that 2.5 times 10 to the minus 2 moles of S208, 2 minus, that's how much reacted every time. Because we put the same amount of S203 in every time, so that's how much reacted, and it was always in 25 milliliters. So the change in concentration, no matter what we started with, this is how much the concentration changed by 0.0010 molar. So when it turned blue, 0.001 molar, the concentration went from 0.2 down, 0.001 went to down to what would that be? 0.1999? Okay, good math there. Okay? So every time, so then it went from 0.064 down to 0.063. Every time it went down by 0.001. Okay? So now I know that my rate is always going to be this. So the only thing that's going to vary is the time. Because my initial concentrations changed, my rate changed. So you go through and you calculate your rate all 7 times. Now on this one, I used y'all's class average. So I kind of did the work for you, since most of you didn't want to be too gung-ho. All right? So when we look here then, so now I have my rate and I have my concentrations. So now we can fill in and make our own chart. So if we do that and fill in the table, it is coming on, yes. Okay. Now, if we look at this, we can now see that if we compare experiments 5 and 7, this stays constant. Now this is just like a problem in the book. Okay, guys, middle row, just give me a second. Okay? We compare, this is times 2. So we come over here. So when in our experimental data, this is times 1.88. Approximately 2. So what's the order with respect to the S208? It's first order. Then we do the same thing here. This is times 2. Now, you could have used this one, but then you got to figure out, well, 0.064 times what is equal to 0.08. Okay? So it's not going to be a whole number. I always try and find the one that's going to be a whole number, so that's why I picked 2 and 4. So this one came out to 1.91. Now, Macy asked a great question. Why didn't everybody get the same time? It's supposed to be a clock reaction. We all use the same stuff. Why is it different?
We use the exact same amounts.
Okay? Because some of y'all didn't read the bottom of meniscus exactly right. Okay? You might have been a little bit above, a little bit below. What else?
Starch.
What about the starch? Well, what would using 8 or 9 drops do? No? I mean, it might make it a little bit deeper, but it's...
The more there is, wouldn't it be easier to react like it would react sooner? Because there's more concentration.
But it's really not dealing, it's not part of the reaction as far as one of the reactants for changing its concentration. But what's more volume going to do? Dilute it some more. Okay, so it may make the concentration really not be consistent, the same one every time if you use too many drops. Okay? And the other thing is some of y'all waited until maybe after you swirl it to start. Some of you maybe as soon as it hit, you hit start. Some of y'all may have waited to stop it until it went completely blue, versus some of y'all went when it first started being blue, which is, by the way, when you were supposed to do it, when it first started turning blue. Okay? Some of y'all maybe looked away and then said, oh, crud, and then stopped it. Some of y'all may not put starch in and just said, well, it turned yellow. Okay? All right? So there's a variety, but all of those are human errors. Now, we don't ever say human error in a source of error. We specifically say all those different things that I just went through and listed. Okay? But that's why we have a variance in the time. If I was really kind of looking at these and I put your averages up there, I probably would have thrown out maybe 1 or 2 of the lowest ones and 1 or 2 of the highest ones and then taken the middle. And that probably would give us even better values on this. But we can see it's pretty close considering the crudeness of our technique.
We did it one time actually without starch, and we got like around the same time with starch, so do you really have to do it?
Well, the starch makes it more dramatic. I think the starch makes you see the color change faster because the yellow is faint and then it grows and becomes more and more yellow. So I think you're going to get a more accurate time because of the distinct blue color that forms. But the yellow color that forms is definitely the dissolved iodine, very dilute iodine solution. So, but I think it's just easier to see the color change with the starch so you get a more accurate time.
What is the actual time it should take for experiments to happen?
Well, I mean, you could maybe go in and figure that out as far as the rate is concerned. You'd have to work backwards. If it's if it's a first order with each one, you put it into your rate law and then solve for the rate at those, and then come back, and once you have the rate, the change in concentration, so then you have to figure out time. Or you can just kind of play around with it and try and see what makes it come out exactly to. So, okay? But in an experiment, there's really never an exact right answer. That's what we're doing it for, is trying to figure that out. Now, how close did your values of K come out to each other? Because you went through and you calculated K 7 times and then got the average. Were there any outliers? If you have one, that probably means, okay, that one probably is the one that messed up. You may have done something wrong there if one of the K's was way off. Okay? But did they come out pretty close? Did they come out the same, at least order of magnitude, same power of 10? Okay? So that's pretty good. Okay? So that's all you have to do for this is go through and calculate your concentrations, calculate your individual rates. Now, for 5th and 6th period, I used 3rd and 4th class average. You might want to go through and use your class average and kind of see how does your values compare to the class average. See if you're above average or below average. See if your values are better. Hey, when I say better, what am I looking for in terms of better? What whole number? What whole? The change in the rate, right? Is how close to the whole number? How close to the 2 did your change in rate actually come out to? Okay? So, the farther away from 2 you are, the greater your experimental error is. Okay? Now, all you have to do for this lab is these calculations. Answer those questions. Ladies, listen. Okay? Are these calculations that are on the last page. Okay? Where are they? Okay? So you're going to, obviously you'll have observations. You always have observations. Okay? Let's make that due on Monday. You're pretty much done. You should have had time to be pretty much done. But I need you to understand how to do that. Now, test is going to be on Tuesday. Well, let me take that back.
It's not Thursday, not Thursday.
It's going to be next Thursday.
No!
Okay? Now, because I'm not going to be here. Okay, that way we don't waste the day.
Can I take it Wednesday?
I know, 3 Thursdays in a row.
Can I take it Wednesday?
Well, the test is a bunch of questions. You do your best. Yeah, I'm not going to be there for the AP test. So you gotta. As my wife says, you got to put your big girl panties on and. Okay. All right. Listen. Hey. Yes. Now listen. Stop. Test will be next Thursday, but we're going to start new material before then. Okay? A push test is Thursday too?
Yes. Push
Yeah. Tell A push to change because I'm not going to be here, so I can't change.
We should have it Wednesday.
Okay. All right.